Hello and welcome to York Observatory YouTube Teltube, the online astronomy astrophysics program written and presented by the students, faculty, alumni, and friends of York University. Tonight you may notice something a little bit different. We're on a whole different channel. We're streaming with our event partner Space Canada, broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. York YouTube Teltube broadcasts every Wednesday at 7:30 p.m. local Toronto time. For any questions or comments you have, our past shows, or if you have any suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us at Twitter or Instagram with the handle at York Observatory and Facebook at Allan I. Carswell Obs. I'm Obada, and I'm here with Matt, Maheen, Dorsa, and Dian. And we're here from the Allan I. Carswell Observatory at York University. Tonight we've got a great special event in collaboration with Space. The observatory at York campus is in Toronto, and we'd like to welcome you all to our show to acknowledge the traditional land that our telescope is on. The observatory acknowledges its presence on the traditional territory of many indigenous nations. The area known as Takaranto has been taken care of by the Anishinaabe Nation, the Haudenosaunee Confederacy, the Huron-Wendat, and the Métis. It's home to many indigenous people. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. Our stargazing and astronomical efforts join the long history and current practices of astronomy for this land. The observatory looks forward to continuing to learn and revitalizing our knowledge in this area.
Thank you so much for that intro, but hello there, everyone. Matt here. So before we get started with our main show, we wanted to give you actually a little update on what you can see this coming week. So this week we'll have the moon up in the night sky, as well as the Pleiades, Uranus, Aldebaran, and Capella. So the weather's getting better, as you may have seen, a little warmer and hopefully a little clearer in order for us to enjoy such an amazing view. We see the moon as something common in the night sky, but even though we don't actually take into account all the fascinating facts that our moon has, that are necessarily a common thing to see every day. We can start by the fact that the moon and the sun, thanks to the distance between the earth and the moon, and well, the distance between the earth and the sun, are close to a perfect one-to-one ratio from our perspective, which means that we are able to see some amazing eclipses when these two meet. Now, how does this happen? Well, the sun is happens to be roughly 400 times larger than the moon, but oddly and interestingly enough, the sun happens to be also 400 times further away than the moon. So 400 and 400, which gives us this little to close to perfect ratio. And talking about interesting facts, have you heard about binary stars? And well, if your answer was yes, then did you know that sometimes those binary stars can come already in pairs? In other words, a binary star system can be the pair of another binary star system. And don't believe that's possible? Well, just look up, because you may have seen this countless of times in your life without even knowing. And yeah, I'm talking about Capella, that object in the night sky that may appear as just one single star is actually a quadruple star system. Yes, quadruple, with two pairs of binary stars, forming what is seen as the third brightest star in the northern hemisphere. And we can't end our WhatsApp in the Sky section tonight without talking about the Eye of Taurus, or what was seen as one of the guardians of the heavens in ancient Persia, more specifically, the Watcher of the East, Aldebaran. Located in the constellation of Taurus, Aldebaran's name is derived from the Arabic word Aldebaran, meaning the follower, since it appears if Aldebaran was following the motion that the Pleiades star cluster does in the night sky. And this apparent condition wasn't only observed on this side of the world, that as a matter of fact, but over in the area of what is northern Mexico as well, where the Seers people saw Aldebaran as the star that goes ahead, or the one that gives light to the Pleiades. And well, just like the Pleiades, this little interesting portion of info has been what goes ahead of this exciting event that we have prepared for you tonight. So over to you, Julie.
Julie, you are muted.
Thank you.
I wasn't going to tell you, but anyway.
Of course I am muted. Yes. Anyways, I'll start again. Thank you so much, Matt and Obata, and thank you all for joining us tonight. I am Julie Tomei and the chair of the Space Place Events Committee. Big thank you to Kirsten Van Stone, who is the more familiar face to those of you who are used to joining our Space Place events over the past couple of years. She's been the on-camera talent of our virtual events thus far, and she is running things in the background this evening. And she is, of course, one of our board members. So for those of you who are joining us from the Allan I. Carswell Observatory audience portion of this and are unfamiliar with Space Place, we are a group working to bring a large, iconic 21st century planetarium to Toronto, and we hope to do that very soon. This evening, we would like to thank our Jupiter sponsors, MDA, for their support of tonight's event. So, Kirsten, could you please play the MDA video? Thank you. And we would also like to thank our Mercury level sponsors, Global Public Affairs and Stratia. So without further ado, let us introduce our two main speakers for the evening, who, I mean, really need no introduction. We have Dr. Elena Hyde and Professor Paul Delaney. Hello, hello.
Hi there. Good evening, everybody. Glad you could join us tonight.
It's been wonderful being here, and so I believe we're currently up to about slide 4 in our presentation. Very excited to be here. So we're just going to take a little turns sort of introducing ourselves, just in case anybody over at Space Place channel doesn't know me. I'm Elena Hyde, a somewhat new professor here at York University, and I recently took over as director from Professor Paul Delaney, who you're going to meet shortly. I am an Australian, which is not an unusual state for a director of the Allan I. Carswell Observatory. And I have a strong interest in astronomy and data science, and I love telescopes. So I'll let Paul go over and introduce himself here next. So take it away, Paul.
Thank you very much, Elena. Yes, there is this theme running about Australian directors of the Allan I. Carswell Observatory. Gotta love it. I am actually now Professor Emeritus. I actually stepped down from full-time activities at York on January 1st of this year. I must admit, retirement, best job I've ever had, although being at the observatory for the previous 35 years was absolutely marvelous. I've got lots of history with the place. I can tell you all about the things that you don't want to ever know about, why things go bump in the night when they shouldn't. Happy to be with Elena tonight, walking you through two really terrific facilities and, of course, introducing some of our marvelous students who revel in the opportunities to spend time in the domes.
Indeed. And things that go bump, things that go fizzle, and things that go zap are all things that we worry about a lot. Some of those things you will, in fact, be meeting tonight. So we're going to start with a little bit of a sort of a double introduction. So Obata, you, I believe, have slide 5. Obata is going to just tell us a really quick little blurb about some of the operations and facilities at the observatory if you haven't heard those before. So if we can get that image put up, there you go. Take it away, Obata.
Yeah, so our observatory consists of 2 domes, and each one houses a telescope, the 60 centimeter telescope, and a new 1 meter telescope, which is the largest telescope on any Canadian university campus. Each of these telescopes is equipped with a CCD camera, which is a very sensitive camera used for astronomical imaging. We also have a 40 centimeter telescope and many other smaller 20 centimeter telescopes. The reason all the telescopes have names such as the 1 meter or 60 centimeter is because they have primary mirrors that have the diameters with those sizes. So a 1 meter telescope has a primary mirror with a diameter of 1 meter. Most of our telescopes are reflecting telescopes, so they use mirrors to gather light. The amount of light they can gather depends on the size of the primary mirror. The bigger the mirror, the more light they are capable of collecting. This makes the diameter of the primary mirror a very important feature of a telescope, so we use that to name them. All of the telescopes are used for many astronomical things and studies.
Indeed, they are. And of course, this is a lovely slide that was up for the just showing what the telescopes look like here. We, of course, have 3 notably large ones, the 40, the 60, and now the 1 meter telescope, which we're going to be sort of showing you about. And we're about to go over. So what we're going to do is actually have June, who's in the crew with a camera at the walkover bridge, walk up and show you what it's like going into the observatory, up into the 60 centimeter telescope and the warm room. So over to June's camera, which should be on now. So this is June at the walkover bridge. So thanks, June. If you want to go ahead and go up into the telescope area so you can see we're leaving Petrie here. June is unfortunately a very fast person, so we're going up the stairs. The red lighting is helping with night adaptation, of course. Paul, you might recognize some of our historical imagery there on the wall.
Absolutely. Yes, indeed. We've got to really update that sometime, Elena.
And here we go into the main entrance and over to the 60 centimeter telescope. And that is the first of the domes you saw in that previous image from the outside. So June is now inside the dome, pointing up at the 60 centimeter telescope, which is not quite parked, is it, Paul?
No, it's not. It was active last night, and we were hoping that it might get active tonight. So we left it more or less on declination target for one of our variable stars. The telescope, of course, Elena, is our oldest telescope that is still in active use. It was put in back in 1968 when the observatory was first established. So this is the workhorse. This is the legacy, if you will, compared to the other telescopes that folks will be seeing tonight. That's right. Competition Associates. Very good, June.
And it is actively running, as Paul mentioned before. This telescope is still completing research observing, and it actually is hooked up to run on a target automatically and close itself down at the end of the night. So all appearances aside, this is a really excellent workhorse. So I'll just get June to go over and see if I can get him to zoom into the control panels for the dome rotation, which are on the side here. We should be able to get that aside. So this is the main dome controls. We're not quite sure if it's going to rain, so I'm not going to have him open the dome. But as you see now, he is actually rotating it. So that's the flat field screen, shall I say, going by, rotating around, and that dome will rotate so that it can stay in line with the telescope as we observe. So it is overcast right now. If you are watching the weather, which we are quite keenly, we will not be able to open the shutter because we can't have any water or any more water come into the telescopes.
The telescopes do not make good rain gauges, and we are mightily opposed to them being used for such purposes.
Indeed, we are. The main objective of the dome, of course, is to keep all of the water out. And that is the shutter that you see highlighted by those lovely blue lights up there. And the top entrance is where, of course, we would be able to get light in through the telescope if we could open up that shutter. Very, very nice. So let's have June head out of the 60 here. And shall we go into the warm room next? So this is the first dome. It's not very warm in there. So let's go into the warm room area, which has a patented magnetic curtain. And we'll continue our setup. So here we have Maheen, Dorsa, and Sana, who are running the 1 meter telescope on Milky Way computer. And that is the 1 meter that we were just looking at the side there. So that is the Milky Way computer and Altair. So let me just see if I can get, June, can you walk through the Quail way into the 1 meter? So that's Quail, the new instrument that has just gone on to the 60. And we actually forgot to show you the Quail on 60. So this is a little bit of an oversight. But it is mounted to the side of that 60 centimeter telescope. All right, so this is the 1 meter area that you're seeing now. The dome looks similar, but this is not an automatic dome, so we can't run it remotely. You have to be there in person to show it. All right, so we'll go ahead and have June probably relinquish the camera, and we'll switch over to the OWL camera here. So June, please disengage this, and we'll switch on to OWL. Okay, so we'll get the end back. And while we're switching over, let's see. Let's go ahead and switch onto the 1 meter screen. So this is images we took earlier before that big cloud moved in. Look familiar to anyone?
The moon is always a beautiful object. It doesn't matter what size telescope, but I must admit the 1 meter does an absolutely magnificent job. You feel like you're crawling around inside the craters on the moon's surface. And when the students are wandering by, having a look, you can just see their faces light up at the detail that the 1 meter delivers.
Indeed, and I just love how we are able to get such high, sort of resolution off of these craters. If you collect enough of these images, you can, in fact, make a really lovely mosaic, which a few of our crew have done. You can find them, actually, I'll just go ahead and say it, you can find them for sale in our observatory calendars this year over at the York bookstore. All right. So we'll go ahead and see if we can't get Dorsa or Maheen to go into the 1 meter and turn around the 1 meter camera, or the 1 meter, so that it's facing the OWL camera. So we're just going to send them over at the moment. And in the meantime, let's hop over to Obata. Actually, are we there? Yes, we are. We're already there. So this is OWL camera on loan from the physics department. You'll notice that there's a panoramic view on top and a zoom in at the bottom. That is the barrel of a 1 meter telescope pointed right at you. And of course, it does have a little bit of a counterbalance. So Maheen is in person, moving it with a feather light touch because the motors are not engaged. If they were engaged, of course, we would not want to do that because we'd be pushing against the motors, which would be very bad.
But the one thing to notice is that the telescope is so nicely balanced that very little effort is required to move it either in altitude mode or into azimuth mode. Turning this telescope by hand is a delightfully trivial experience. In fact, so much so that if you were actually in the dome and the telescope was powered up, you have to be very much aware of where the telescope is, because if it decides it wants to move to a new target, it does so silently. So you have to be aware of where you are in the dome. It is that well balanced a telescope.
It is. I would say even it's a little bit of a stealth mode telescope. So actually, since we were talking about how easy it was to move, Maheen, if you're still in there, can you put your hand sort of pushing the telescope with one finger crossed, or have you re-engaged the motors? All right, let's see if we can get it into the camera. So up at the top, you can see in the panoramic view, if you zoom in, she's literally just using just almost like one finger on one hand to push this entire telescope around, which is really, really amazing.
She must
now,
be very, very strong.
This is a superpower.
We do have a question from the audience. The question is, what camera was used to get the moon images you showed earlier?
That's an excellent question. We have all kinds of people here tonight who could answer that. Now, I believe it was Sana and June and Maheen who used a Malin cam, which is an eyepiece camera. It's a slightly lower resolution camera, but it has full color. And so that's what we were using just before this broadcast, actually, when we had a clear break from the clouds.
Yeah, the Malin cam has certainly been a wonderful addition. It is so much quicker to set up and to operate than the fairly standard CCD cameras. While the CCD cameras have got a little higher resolution, for the sorts of objects that we want to use on them for public viewing, you just don't need that level of resolution. And the Malin cam has been an absolute delight for us to use.
Absolutely. And actually, if we go back to OwlCam, if we still have Maheen there, we can get her to turn the telescope a little bit so that Malin cam is pointed at the OwlCam. So we're seeing now mostly the CCD camera, I believe, on the left.
That's right. That's the STXL 6303.
That is a higher resolution scientific camera. So you can turn OwlCam or we can turn the telescope, but the telescope's so easy to move. Here we go. And that is Malin cam with the blinking blue light right up top there. And that's a very much smaller camera, but it works amazing. So it's not as good for, say, photometry or scientific imaging, but for outreach stuff, it's absolutely fabulous. So wonderful work, Maheen. Brilliant turning around the telescope here. And you might have blinked and you miss it, but we had the mirror covers open too. Did you catch that?
I did notice the mirror. Yeah.
Indeed. So we have
Shiny.
the mirror covers open. Now, if we're really lucky, I think we can probably get Sana and Dorsa, who I believe are at the 1 meter still, to open and close the shutters for us again. That is the mirror at the center. So let's see if we can get them to do a quick open and close on the shutter pedals. Now, this is really cool because there are 4 of these, and they actually have a little bit of an overlap, a lip, so that when they close, they actually provide a really nice seal against the elements. We do worry, as mentioned before, about water coming in, maybe dripping in through the shutter, and this helps us protect that beautiful 1 meter mirror from any kind of damage here. And that was the close. And so we'll just open it one more time, I hope.
You'll notice that the tube at the middle that the mirror pedals wrapped around, that is our secondary baffle. So that is protecting the light cone that is coming back from our secondary mirror as it charges back towards the primary mirror and out to what we refer to as the tertiary mirror. So it's a secondary baffle, a little bit like an elephant's trunk coming out of the middle of the telescope.
And that does have its own cover as well that we can stretch over. So that will get covered when we close up, as well as a cover for the secondary mirror, which you can just about see reflected in the primary there. So really lovely, lovely telescope. And as you saw before, creates absolutely beautiful moon images that we can, and all kinds of other things. So, I'll just advertise the calendar later offline.
Nice.
And we should also say that this telescope, it's a plane wave instrument, by the way. I'm not sure we've actually sort of mentioned that, but I'm very, very pleased with the plane wave system here. This telescope has absolute encoders, and it sets exquisitely well to literally within a few seconds of arc from the moment you turn it on. It knows where it is, and it knows where to go upon your input of a particular object. It really is an absolute joy to use. And as you know, as Elena has said, the imagery that you are able to collect from this telescope, absolutely exquisite.
And we just have to say, in terms of a telescope tour, no tour would be quite complete without mentioning this 1 meter telescope is fairly new. So I don't know if we said it was installed in 2019, August 16th exactly. And it was actually installed because of a major grant from Allan Carswell. That is why we're called the Allan Carswell Observatory now. And this telescope coming in 2019 was a real revolution for the observatory. The dome was opened, and the telescope actually was installed through a crane in the center. That dome that you just got a tour of was previously home to our 40-centimeter telescope. That telescope we haven't abandoned. We've actually just we've sent it to live on a farm. If a farm was the atrium across the walkway.
Oh, the 40.
Yeah, Julie remembers the 40.
I do. I was there for first light of the 40.
It's still there. It's been relocated to the Arboretum. So prior to the 1 meter coming in. And since the 40 was so much smaller than the 1 meter, both the platform that you saw Maheen walking around on before and the dome had to be modified to accommodate that 1 meter telescope. And it was so big that when they brought it in, it actually couldn't fit through the shutter all in one piece. It had to be, put craned in pieces. They can't, we're not taking it up the stairs. Airmail, yes. There are some lovely pictures of some very, or I suppose scary pictures.
Yes.
Mirrors on cranes going high up in the air to get into that dome.
We couldn't have asked for a better day, though, on that August morning. It was so calm. It was very clear. The whole process unfolded beautifully. We started at just shy of 9 o'clock in the morning, and first light, and Sana was there for first light that night, was 9 o'clock. So 12 hours from start to finish for the installation. It was really that smooth a process, but very nerve-wracking. Seeing your primary mirror dangling 5 stories in the air from a very thin cable, as far as I was concerned, really was not for the faint of heart. But it was all professional.
Did you have any fingernails left at the end?
Not many. Not many.
I'm sure we have, a lot of people interested in telescopes, obviously watching this evening, and it's an interesting design of telescope. I mean, I think most people are used to seeing eyepieces sticking out of the back end of a telescope, not off to the sides. So, what can you tell us about this particular telescope design?
It's a little bit like a coude. It's what they call a Dahl-Kirkham design, so that the primary mirror is where the light is being collected from the night sky, charges back up to a secondary, so that sounds like a Cassegrain, charges off the secondary back down, but there's no hole in the primary mirror, so this is where it begins to deviate from what most amateur astronomers are familiar with. That's where the tertiary mirror is. We refer to it as M3, and it can send off light, which is obviously converging, off to 2 different ports on either side of the telescope. And you saw very good. You saw the the Mallancam out of one port, and you saw the STXL out of the other port. So very quickly, by modifying the position of the M3 mirror, you can reach 2 differing instruments, or 1 instrument and an eyepiece. So this makes it a really compact design. This is an f6 telescope, so it sort of fits comfortably in our 7-meter diameter dome. Very, very neat design.
Indeed, and it's very compact, especially if you can recall the first part of this tour where we looked at the 60 centimeter telescope. Its CCD was on the bottom, and when the telescope tilted up, the entire instrument had to go up in the air. This avoids that problem. The instruments sit on the side, and they don't have to go up in the air. They just sort of rotate around as the telescope moves, and then when it goes the other axis, they don't really mind at all, really.
In fact, we designed the platform and the pier and the telescope also that theoretically people could walk onto the platform and straight up to the eyepiece. And for this, quote, standard adult, you'd just be able to look straight in without any stairs or anything. Of course, I will now freely admit, first time on in public, that I had designed it so that I would be able to walk straight up, and I'm only 5'9", and I missed it by 2 centimeters. So I actually have to go up on slight tiptoes to get to the eye. I was really annoyed that I miscalculated by that 2 centimeters. But anyway, it's comfortable for anybody who is 5'9" or more.
So some of us have to still use a little ladder. That's okay.
I bought one. It's okay.
There is, and that is true. There is a small ladder just off to the side. You might have seen it in the video before, and that is what we commonly use for eyepiece viewing, and also, of course, for putting the mirror covers on. But this is a wonderful example, actually, of the sort of what we get with perfect lighting conditions, picture of the 1 meter telescope. We do actually also have a really nice picture talking about the installation of this telescope. If I can get Obata to go down to slide 16, we'll go and look at the, I believe we have first light, which was in 2019. So we've seen recently some moon images from the Malin Cam. This was pre-Malin Cam era, and this was a crew from Planewave with Paul. And so you probably remember this image.
Oh, yes, and so will Sana. This was a 300-second exposure around about 9:30 in the evening back there in August of 2019. And when this came up on the screen, it sort of sucked my breath away because, as you can see, the focus was really, really good. And the collimation was really, really good. And 12 hours before this was in 6 pieces sitting on the ground. So the fact that it was able to show us this level of quality image on the first night was really stunning. It was just excellent. Obviously, it's just through one filter. We didn't attempt color on this, and I think it was the R-band filter that we were using, but it showed immense detail. And the following night, we came back. We had 2 clear nights in a row, so I don't know. I should have bought a lottery ticket. And finished the collimation process. We were able on the Saturday evening to be down to 2 arc seconds of seeing, which is really quite rare at York. It was just absolutely picture perfect for the guys from Planewave to put this telescope through its paces.
Yeah, I have to say we do suffer from light pollution a bit, and not
a bit.
Wonderful. Well, it's better now that we have that dome across the football field.
Yes.
So that has improved things, but I haven't seen too many nights of subarc second seeing.
No, not at all. Not at all. But yeah, this was a great image that particular night. Julie also mentioned that she was around for the 40 centimeters first light. That was back in December of 1999. So as you can see, between 1968, 1999, and 2019, there has been this wonderful progression of telescopes to the Allan I. Carswell Observatory.
Yeah, so I'm looking forward to our 2 meter telescope.
Oh, wow.
Nice.
Invite me back.
There's also been a wonderful progression of, a certain level of automation. When June was showing us images in the 60 centimeter, and you were talking about, oh yes, and we can just turn this on and it'll work all night and then it turn itself off in the morning. And I was like, not in my day.
No, you were there observing for 6 hours at a stretch, and you were writing down or hitting computer code to make sure it was storing information. We have been observing SX Phoenicius type stars, that's a variable star, since about 1996. So that was in your era, Julie. And you're right, none of this was automated. All of it was hard yakka, to use a good Australian expression. And it was a challenge. But starting just after the turn of the 21st century, the 60 centimeter began to receive semi-automated upgrades. First for the telescope with new sensors to be able to tell us where the telescope was pointing, the dome so it would rotate and keep the shutter in front of the telescope. And now, by and large, with a wonderful program called Dome Tracker, that the students, starting with Jesse Rogerson, all the way back in 2003, 4, 5, somewhere in there, we now have a telescope which we have great confidence in for observing for 6, 8, 10 hours and shutting itself down at the end of an observing run, waiting patiently for the observers to wake up the next morning. It's been a huge improvement as far as the amount of data we can collect. And the most recent paper actually was last December on our SX Phoenicia star. So it continues to do wonderful things, and the students get their hands on real data, and they analyze that data, and then they publish that data. So it's a great package.
Yeah, we are keeping the SX Phoenicia stars going, so no worries there.
Yeah, it's an amazing program. It's totally longitudinal. Like since 1996 is, nothing to scoff at, and it's true. It's a fantastic opportunity for undergraduate students to get a real taste for what scientific research is all about with real data, real publications, which is, fairly unique. And it was definitely, the observatory was a big draw for me to be a student at York.
And of course, not just to be a student, but to be, hands-on. I mean, you were able to spend time at the observatory, both from a science perspective, from an outreach perspective, and I'm pretty sure you were up there several nights just because you wanted to use the telescope for yourself. I mean, that's all part and parcel of it. How many students get a chance to play with this size telescope and go and have a look at anything they want?
Well, speaking of contrasting telescopes, I believe we actually have a fun fact from Dorsa. So I think this may or may not go with slide 21. But Dorsa, if you're there at the 1 meter, you want to chime in?
Hello, can you hear me?
Yes, we can hear you.
Okay, great. So in this slide, we have Polaris up, and actually a few facts about it has been outlined for you. It's basically, I think it's really cool that Polaris has been aligned above the North Celestial Pole of Earth around 2,000 years now. And the fact that it's the brightest star that appears to stay stationary in the night sky. And it is actually 46 times bigger than the sun. So that's something to ponder about. But yeah, it's something that's always up in the sky. You can always see it with a telescope if the clouds let us, obviously. But yeah, I think it's really cool.
Also a variable star.
Yes, yes.
Yes, it's a Cepheid variable. There's always been a little bit of discussion and debate about that. It's not a typical Cepheid, but as you point out, it's always in our sky at this time of evolution on this planet, and it is a variable star.
And actually, if we want to do the Milky Way screen computer share, we can go to the plane wave interface, and we can actually see the location of Polaris in the sky tonight. So this is our control software for the 1 meter telescope. Which, as you can tell, is not pointed at Polaris at the moment. But Dorsa's, location, we could easily go there because, of course, the North Star is never going to set from our location. So we can view this pretty much any time with our telescope. It's a great target.
Yes, it's always high in our sky, around about 46 degrees above the horizon. So, yep, it's always there. And anybody who is out sort of orienteering, you don't need to have a telescope to find it, and you'll always know where north is. So very handy in that regard. Look to the north, and then all of your other directions are obvious from there. Off to your right-hand side will be east, off to your left-hand side will be west, and of course directly behind you, opposite to the direction of Polaris, is south. Quite
Yes,
useless in the southern hemisphere.
Just make sure you learn how to find it. It is not, contrary to popular belief, the brightest star in the sky. If you start following that, you will not be going north.
Very good point, Julie. Very good point.
Well, especially if the brightest star in the sky happens to be Jupiter, you'll really be going the wrong way.
And then there's the ISS that periodically wanders by, blazingly bright object, even brighter than Venus on many occasions.
Well, speaking of fun objects, we do have another pretty fun one actually coming in from Obata. Now, I'm not sure if Obata had a slide to go with this, but why don't you go ahead from wherever you are, Obata, and give us your fun fact next.
My fun fact is many common observable objects in the night sky start with the letter M, such as M1, the Crab Nebula, or M31, the Andromeda Galaxy. These objects all belong to something called the Messier Catalog, which is a list of around, it's exactly 110 objects in the night sky that were initially recorded as a way to distinguish objects that are not comets by Charles Messier in the late 18th century.
We can see some of those on that plane wave interface that was up before, of course. And the images you see in the background here, these are not the Allan Carswell Messier Marathon, but we do actually have one, which was run notably by Guggen and Sana. Sana, do you remember when that was?
I certainly do.
If you're there, I believe Sana's on the 1 meter, so we might not be able to get her.
Oh, there's Sana. She's on Milky Way.
Are you able to join with audio? That's the question.
Yep, we just need to unmute. There we go.
Hi.
Hey.
There she is. Messier Marathon. What do you remember?
Oh, that was a fun night. Me and Gagan were up here for the entire night. We got, I think it was 80 out of the 110 Messier objects.
Wow.
It was a lot of
Good
fun.
for you.
Yeah, the 1 meter made things very easy because it's such an easy telescope to use. So there was a lot of driving around, getting a couple minutes on each object. We got multicolor images on a few of them, so just images of the object in 3 different filters using the CCD. And yeah, it was a lot of fun. I'd love to do it again.
It was
and maybe get closer to 110 objects this time.
You were observing that in March of 2019, literally the week before COVID shut down campus. It was the weekend immediately before campus was basically evacuated. So your timing was exquisite. You managed to sneak it in.
Yep.
So that would have been 2020, yes?
No, 2019.
2019.
29. Well, if it was the week before.
Oh, sorry.
Would have been
2020. Yep.
I know.
misspoke.
Time means nothing anymore. We do have a question from the audience, because we were talking about having undergraduates have access to this kind of observatory. So the question is it common for undergraduate students in Canada to get this much access to an observatory?
No, that's the short answer. Certainly some observatories across the country do engage in undergraduates using the telescope. I'm certainly not going to say that they do not, but the extent to which we give literally 1 meter time to our undergraduate observers. So they are in control of the telescope, and they'll either be doing science or they will actually be going off to look at objects themselves, a bit of astrophotography. The extent to which we extend that on the 1 meter and previously on the 40 and the 60 is quite unique. But certainly other telescopes across the country do engage in that activity, but not nearly as much as we do here. And certainly over the 3.5 decades that I've been here, it's been first and foremost the opportunity for the students.
And I just like to say, because we have been talking about observations and it is March, if you are looking at going ahead and trying the Messier Marathon yourself, I believe we are in near Messier season. So
you
actually have a pretty good chance of being able to get all 110 objects if you so wish with your binoculars or telescope.
Plan. Did I say plan? I'm meaning plan, because to get all of those objects in across the course of an evening, it really requires you to be at sunset, working your way methodically from the most westerly objects eastwards to literally sunrise. It just doesn't happen. You do have to plan accordingly, but it's very, very satisfying.
If you get the right ascension and declinations, all you need are, of course, the rise times for your location. And I'll just say that we have been putting some observers tools up on our Allan Carswell Observatory website. So if you'd like to use any of those, please feel free. Getting the rise and set times will absolutely help you with this, because you don't want to observe the objects that set first last. Absolutely.
No.
That's a classic error. You end up missing one, and then you've only got 109 or something. So we have Messier fun facts all over, actually. So I believe we have a similar one from Dean. Shall we go to that one next, Dean?
Hi. Yeah. I have some fun facts about the moon, actually. So firstly, the moon is Earth's only natural satellite, and it's actually the 5th largest moon in the solar system. The moon's presence helps stabilize our planet's wobble and moderate our climate. It is about 240,000 miles, or about 385,000 kilometers from Earth. And the moon actually does have a very thin atmosphere called an exosphere. So there you go. There's a couple facts about
that. I see. You're doing your moon ones. Well, in that case, let's put up the Milky Way moon images that we took earlier from the Milky Way computer. Now, Sana and Maheen, I believe you have those images up on the background. So this is not the live image, but this is pretty close, taken earlier tonight. That is, of course, the mysterious moon, as mentioned by Dian. We just can't get enough of these, really. Just want to make a big blanket out of it and wrap yourself up in it.
Might be a little scratchy.
Would a moon blanket be scratchy? I heard it's really like low density, and I think it's like fluffy. So.
I'd be worried about the moon dust personally. I think that's perhaps what Julie was more concerned about. But yeah, the moon is always a wonderful object to look at. You can never get enough of the moon because, of course, the differing phases give rise to differing appearances. It's sometimes, in fact, incredibly difficult to identify areas on the moon from differing phase angles. When it's like at the moment, early morning on the moon, the sunlight is casting long shadows across the surface, makes it a lot easier to pick out, in my opinion, the craters and the larger mountains. When it's closer to full and the sunlight is beaming straight down like high noon, gosh, it's sometimes hard to find the craters on the moon, in my opinion.
Agreed. And it is really interesting, the optical illusion you can get with some shadows, where you can get effects where it's really hard to tell if it's a mountain or a crater because of the direction the shadow is going. And you can be looking at a moon image being completely convinced that it's a mountain, and then actually it rotates a little bit and it's a crater, and you're just like, what? So right. The moon really never gets old, and this is why, of course, a lot of people were really interested in sort of keeping the conversation going about what we have rights to do on the moon's surface, especially with that recent accidental collision of a rocket booster on the far side, which I believe, Paul, you were talking about this just the other day.
Yep, it was a Chinese booster by all accounts. China has not owned up to that, but all of the tracking data and indeed even the spectroscopy of the paint on the rocket booster all suggest that it was a leftover upper stage of the Chang'e 5T technology demonstration mission from 2014. It didn't land on anything, which is fine, but as we're all aware, the moon is becoming a busier place. The Artemis 1 mission later this year, Artemis 2 and 3 in the next few years, Lunar Gateway, an increasing number of vehicles on the surface of the moon. This is an area which we don't want polluted like we have Earth orbit with unnecessary satellites and so on. We need to be a little bit more mindful, be better stewards of the space environment around the moon, and to try to pick up the pieces here around Earth's orbit too.
Indeed, and the moon is it means many things to many people, but it's really an absolute geological record of the history of our solar system going back billions of years, because you can see the history in the cratering patterns on the moon, and it's actually kind of a living record of what has gone before. So in that sense, it's to me, I've always thought of it as a really kind of almost a sort of a magical reference, because it's providing us such a detailed record of such a long period of time that's outside of our common human temporal conception, if you will. But that's just my 2 cents.
No, you're right. It's a time capsule in many, many ways. Unlike the surface of the Earth, which is continually reshaping itself because of the various erosive forces, the geological activity beneath our feet, and so on, the moon has none of that. And literally, what you see is frozen in time. The lunar Maria from 3.5-ish billion years ago, the lunar highlands from closer to 4 billion years ago, and so on. This is a snapshot of the earlier moments in our solar system. It's one of the important reasons, as you say, to keep it in a relatively pristine state, to be able to go back and examine the information, to give us more insight into our solar system's formation. The moon is a wonderful object for all sorts of reasons, and it's right on our doorstep.
Indeed. And now I think we do have one more actually fun fact that has been prepared by one of our crew. Maheen, are you there in the 1 meter, I believe? Or are you in the warm room?
Can you hear us?
Yes, I can hear you.
Yes, I'm here.
All right, go ahead. So you've got a fun fact is it from a Messier object or something else?
Yep. So my fact for today is, did you know astronomers usually go through several steps of image processing in order to achieve an image which highlights important features of the astronomical objects necessary for research? So as we can see on the slide, this is an image compiled by ESA, and it consists of all the steps they went through to get the final image on the bottom right.
That is wonderful. That's a really cool fun fact. And actually, if we hop on to slide 20 from Obata, I believe we do have some extra astrophotography here, which includes a few. This is from the 1 meter telescope. We have Stefan's quintet on the left there. It's a group of 5 galaxies. And this is after image processing, taking several images, stacking them together in several different filters. It's a really lovely galaxy group located in the night sky next to the Deerlit group. On the bottom right is M1, the Crab Nebula, which is very famous. And this is pretty much real color, but of course it's been enhanced a little bit by that image processing mentioned by Maheen. That Crab Nebula being a supernova remnant, which is formed by the matter left over from an explosion of a massive star. And then the top right, in a little bit smaller than the other ones, that's NGC 6503, which is also known as the Lost in Space Galaxy. So any of you folks who've seen the old Lost in Space, not the new one, this was the Lost in Space Galaxy. I'm not sure if the new reboot of Lost in Space uses the same galaxy. So if you know that, feel free to tell us in chat. It is a dwarf spiral galaxy, which is at the edge of the local group. So this is astrophotography. And, you know, we are currently doing astrophotography, and quite a few of our folks are actually playing with some images that I believe June and Laura got not too long ago, a whole set. Was it the planet Uranus or some combination thereof? But we love to do this kind of image processing to bring out the details of these astronomical objects. And I'll just say, since you're in the warm room, Maheen, can you grab the warm room webcam and actually just show the two different computers really quick, so folks can see the computer setup of Milky Way and Altair. In case you were wondering what where the real work happens, a lot of it is behind these computer screens. We have a workstation for the 1 meter set up here where everyone's based tonight. And over on the other side, we have Altair. So if we get Maheen to just point at the other computer.
To your left, Maheen, to your left.
To your left. There we go. That one is currently off because it is too cloudy to open. But this is where we run Dome Tracker. And that is a different control software than what you saw for the PlaneWave interface. And it does actually run remotely, so we can dial in there and run it, and then close up remotely if we need to. All right, so that is, I think, the last fun fact we have for the crew that I've seen on the list. So what I'm going to do now is actually get Maheen or Dorsa or Sana, one of you, to please go into the 1 meter. And the rest of you stay on the control, and we'll switch on to OwlCam. And what we're going to do is try to turn the telescope around so that everyone can kind of see. Since this is a little bit of a sample observatory run and a tour, we'll actually do a little close down of the telescope as well. So you saw it open before. So it looks like, there we go. There's our owl camera and our intrepid crew going across. And so if Sana, if you're there, if you could close the shutters, that's the first step, is on the computer control software interface. We close those pedals, which go through, and that you can see them closing now. The mirror is getting covered. So that's 1, 2, and then 3, 4. So they sort of close in sets of 2. Then we've got mirror covers, which are going to go on. I believe that's going to cover the baffle that Paul mentioned before. And you can see we've actually picked someone who's tall enough not to need a ladder. So that was June. That is the secondary. So can we get the OwlCam turned up a little bit so we can see the back of the secondary? If you can. Just to show where the mirror cover goes. So that's the back. And you can see the mirror cover is actually on there, like kind of like a little hat that it wears. And so that's the cover around the edge that you see. Very nice. Excellent OwlCam. And I'll just say, in that panorama, what you were seeing up on the roof there when the camera moved was actually the power that the little feet for the shutter motor have to connect to on the dome in order for us to open the 1 meter dome. So that is the 1 meter telescope, all closed up for the night, basically. All we have to do now is, of course, turn it off and pack up the computer and everything else. So we are actually approaching the end of the tour. You've seen everything turn on. You've seen everything turn off. We can't open because of the clouds, but I think we've managed to show you everything we could.
Good night, telescope.
But of course, you can come back on any Wednesday night or Monday night for that matter. Wednesdays at 7:30 or Mondays at 9. And weather permitting, we're more than delighted to be able to show you images live from the 1 meter telescope.
Indeed, and I believe for our last outro here, we'll go ahead and pass over to Matt, who is our student coordinator. Matt, if you're there, take it away.
All right, well, everyone, so you have been listening to a special broadcast with the Space Police Canada that we had tonight with the Allan Carswell Observatory's weekly Tele2 broadcast crew. And we'd like to note that, like our other shows, that this broadcast is written and presented by the students, faculty, alumni, and friends of York University. So the hosts this evening have been Obata, Maheen, Dien, Dorsa, Laura and myself, Matt, and we have been with Julie and Kirsten from Space Place Canada and our special commentators. And of course, let's not forget one of the important members of our staff, June, who's always there for us to help. And well, also Professor Hyde and Professor Delaney. And well, now make sure to leave any comments or questions in the comment section of the video as always, and talk to us in the chat right now if you have any questions. We will be around for the next 20 minutes to answer them. And you can learn more about the Space Place at spaceplacecanada.ca. And by the way, all of our programs are free, but if you would like to make a donation, you can see our website up at observatory.info.yorku.ca. You can always connect with us on Twitter with the handle at York Observatory and check out our website for show notes, content, updates, and contact info at observatory.info.yorku.ca. And well, thanks for tuning in and clear skies and have a great night.
Clear skies, everyone.
Good
Cheers.
night.
Thanks for joining us.